my dear students. Welcome to the class 10 science crash course. Today we are going to start the chapter chemical reactions and equations. Yes, this is a very important chapter. What are the concepts that we will be studying here? Are introduction about chemical reactions. How do we represent a chemical reaction in the form of an equation? And how do we balance a chemical reaction? Then we come across chemical reaction types like combination reaction, decomposition reaction, displacement reaction, and one more is there double displacement reaction, exothermic reaction, endothermic reaction, and oxidation reduction. And also we will be studying corrosion and rancidity. Yes, okay, without delay let us move to the chapter. So guys, do you remember physical changes and chemical changes that you have studied in the grade 9? Yes, in order to understand about the chemical reaction we must know what is chemical change. Yes, what about physical change? It is accompanied by change in physical properties. Okay, whenever there are change in the physical properties, then we say that physical change has occurred. Means here what happens, there is change in the appearance or there is change in size, shape, etc. So that chemical composition of a substance or identity of a substance is not affected, it remains the same. Okay, here no change in chemical composition. Okay, so can you give example for it? Yes, cutting of vegetables. When a whole vegetable is cut into pieces, we get the pieces which has same composition as that of a earlier one, but there is only change in the size and shape. Yes, it is a kind of physical change. Then what about chemical change? Here there is a change in chemical composition of a substance, means a new substance is formed during a change. Okay, change in chemical composition. This results in the formation of a new substance. For example, you might have seen how curd is formed. It is formed from the milk. When milk is converted into curd, what happens there? The curd has different composition from that of a milk. Yes, the taste is completely different, the texture is different, and the chemical composition is also different. Then we say that a chemical change has taken place here. Chemical change. Okay. Then digestion of food which takes place in our body, it is also chemical change. Why? Because the food that we eat consists of carbohydrates, proteins, fats, etc. After the digestion, it is converted into simple glucose. That is also a chemical change. So overall you have to remember that in physical change there is no change in the chemical composition or identity of a substance, but in chemical change the new substance is formed. So now you can easily understand what is chemical reaction. Now how do you define a chemical reaction? Whenever a substance undergoes a change, that is chemical change, then we say that chemical reaction has taken place. So we observe many chemical reactions in our daily life. Yes, can we give example for it? Yes, of course. Have you seen the rusting of iron? When iron is kept exposed to the external environment, what happens? The oxide of iron is formed, that is brownish in color. A layer that is formed on the iron materials is brownish color. There it has undergone a chemical change, that is chemical reaction, by reacting with the external environment. Okay, it is an example of chemical change, that is chemical reaction, rusting of iron. Then again photosynthesis that takes place in plants, it is also an example of chemical reaction where the plants use carbon dioxide and water and form glucose and oxygen from it. Yes, it is a process of chemical reaction. Okay, yes. In your examination the question may be asked like, you have to identify the chemical change. There may be four options for you to identify whether they are chemical changes or physical changes. What you need to remember is, always in chemical change a new substance is formed. For example, if they ask you burning of candle, okay, in burning of candle what happens there? Combustion reaction takes place, that is a chemical change. But if they ask for melting of wax, then it is not a chemical change, it is only changing its state there, it is melting. So we cannot call it as a chemical change there, it is only a physical change. Okay, so please keep in mind, in chemical change there is a new substance formed. Okay, then how do you say that chemical reaction has taken place? Can we observe the chemical change? Yes, of course we can observe the changes when chemical reaction has taken place. There may be change in color, there may be change in color of a substance, there may be change in state, or there may be evolution of gas, there may be change in temperature, or there may be a formation of precipitate. Yes, can we give examples for these changes? Yes, of course. When do you see the change in color for a chemical reaction? In many cases, like rotting of vegetables or fruits. When vegetables or fruits kept for a longer time, means many days, what happen? They get rotten. Once they get rotten, there is change in the chemical composition of the vegetable or a fruit, and also there is change in the color. You can observe easily. Okay, can you observe change in state for a chemical reaction? Yes, boiling of an egg. When egg is boiled, what happens? The liquid that is present inside the egg is converted into solid state because there a chemical reaction has taken place. Yes, then evolution of gas we can also observe. When fuels are burnt, that is petrol or diesel are burnt, the liquid fuels are converted into gases after the combustion. The carbon dioxide gas is released there. Okay, burning of fuels, there may also be change in the temperature. Like when quicklime is added to water, what happens? There is a raise in temperature. Quicklime means tuna. When it is added to water, the temperature of the vessel in which you have added gets raised. That is, it becomes warm. Okay, adding quicklime to water, and then there is a formation of precipitate. Precipitate means it is a insoluble solid that is formed during a reaction. Okay, when there is a solution mixture, after reaction what happens? There is a formation of a insoluble compound there, that is called as precipitate. We will come across the precipitate reaction in the later part. Okay, precipitate means it is a insoluble solid. Hope you have all understood about the chemical changes that we can observe whenever a chemical reaction has taken place. Okay, there may be change in color, state, temperature, there may be evolution of gas, and there may be formation of precipitate. Let me tell you the okay, let us discuss one activity in order to see the chemical changes, how that takes place. Yes, let us see an activity here. Okay, take some zinc granules, then take some zinc granules in a conical flask or a test tube, add dilute hydrochloric acid to it. Yes, add dilute hydrochloric acid to it, then make the observation. What happens there? There the bubbles of a gas are formed. Okay, if you take a conical flask, okay, you are adding zinc granules to it. Okay, then add dilute HCl to it. What are the changes do you observe here? There is a formation of bubbles and there is raise in temperature. How do you observe the raise in temperature? Just by touching the flask here, you can observe that it has become warm, which indicates that heat is liberated. This indicates that heat is liberated. Okay, formation of bubbles shows that there is a evolution of gas there. Okay, because of which there is a formation of bubbles here. Then why it has happened? Because zinc has undergone a chemical reaction with hydrochloric acid to form zinc chloride and hydrogen gas. Okay, it is because zinc reacts with hydrochloric acid to form zinc chloride and hydrogen gas. How do you say that hydrogen gas has produced here? By doing a pop test. When there is a evolution of gas here, we have to bring a burning candle near this. Okay, then what happens? The gas burns with a pop sound. If it is a hydrogen, it indicates that the liberated gas is hydrogen. Okay, it will burn with pop sound. Yes, here these are the two changes that we have observed while a chemical reaction is being taken place. That is, there is a evolution of gas and the heat is liberated, which indicates that chemical reaction has taken place. Okay, let us see another one activity. Take a magnesium ribbon, burn it in a candle flame and make the observations. Okay, you have to clean the magnesium ribbon before performing the experiment. Why? Because the outer layer of the magnesium reacts with oxygen present in air to form magnesium oxide. So we have to remove that protective layer in order to perform the experiment. This may also be asked in your examination, that what is the need of removing the outer layer, or what is the necessity in order to rub the magnesium ribbon with sandpaper. You have to write that magnesium has reacted with the external environment, that is oxygen, to form magnesium oxide. So it is necessary to remove the outer layer of the magnesium ribbon. Okay. Then what you make observation is magnesium burns with dazzling flame, means white bright flame. It is a very shinier, burns with dazzling flame. And again, what do you observe? There is a formation of white solid there, white solid substance. Okay, here these are the two changes that we have observed. That is, it will burn with a dazzling flame and there is a formation of a white solid substance. Why it has happened? Because magnesium reacts with oxygen present in air to form magnesium oxide. That white solid that is formed is of magnesium oxide. Okay, this is the description of a reaction. Yes, magnesium reacts with oxygen present in air to form magnesium oxide. Okay, observe one thing here. This is a description of a reaction. I can also describe the reaction in a simple way. Okay, by writing the names of the substance that have undergone chemical reaction and name of the substance that is formed after a reaction. Yes, I can represent this equation in a simple form so that it is convenient to understand the reaction, and also analysis of the reaction also becomes easy because we will be dealing with the atoms and molecules here. So we need to represent in the form of a equation. Yes, we will understand about equation here. In the two cases we have seen the reactions. Yes, in the first case, that is zinc reacts with hydrochloric acid to form zinc chloride and hydrogen gas. So now I have represented the reaction in a simple form. Yes, these substances which are undergoing the reaction are called as reactants. These are called as reactants. These are represented on the LHS. Okay, and the substances that are formed after the reaction are called as product. I can also represent this equation in simplest form, like by writing the symbols for elements and compounds. Zinc Zn plus HCl gives ZnCl2 plus H2. Yes, this is a representation of a chemical reaction in the form of a equation. So we write the symbols for elements and compounds in order to represent the equation. This is called as chemical equation. So what is chemical equation? It is a representation of a chemical reaction in the form of symbols. So these are called as reactants and these are called as products. Okay. See, observe here, there are two chlorine atoms in this part. In the RHS part, here there is only one chlorine atom. If there are two chlorine atoms here, then there must be usage of two chlorine atoms in the reactant part also. Yes, because it is according to the law of conservation of mass. Means mass can neither be created nor be destroyed. So whatever the mass that I have obtained in the product part must also be same in the reactant part. Both must be equal. So this equation must be balanced. Means how do we balance it? By writing the equal number of atoms on both sides of the reaction. This will give a balanced chemical equation. Okay, if I write here 2, now see whether the same number of atoms are there on both sides. Yes, zinc same, hydrogen same, chlorine same. Yes, now it is balanced chemical equation. So what do we mean by a balanced chemical equation? Number of atoms of each element is equal on both reactant and product side. On both reactant and product side. This is called as balanced chemical equation. Okay, what is the need of balanced chemical equation? It is due to the law of conservation of mass, which says that mass can neither be created nor be destroyed. So number of atoms of elements on RHS must be equal to number of atoms of element on LHS. Yes, so this may be asked in your examination that what is the need of balancing a chemical reaction, that is chemical equation. It is due to the law of conservation of mass, which says that mass can neither be created nor be destroyed. So that number of atoms of each element on reactant side and product side must be equal to one another. Okay. And also in a balanced chemical equation, we will represent the state symbols, means physical state symbols for a reaction. Means for solids we will represent it by yes. If the reactant or product is solid, we will represent it with yes. If it is a solid, then we will represent Yes, if it is a liquid, then we will represent it by L, writing in the brackets. If it is a gas, then we will represent it with G. If it is present in the form of a aqueous solution, we will write it with the AQ. These are called as state symbols. For a balanced chemical equation, we need to write the state symbol for reactants and products. Okay, that will give more information about a reaction. So that simply by seeing the reaction, we will come to know the information like what are the reactants, what are the products, and under what conditions the reaction is taking place. And we will also mention the temperature, pressure, the reaction conditions also. Okay, so there are different elements, molecules. We cannot always remember the physical state symbol for every material, so we can have some general idea about it. Yes, if there are metals, then we will represent it by yes, because almost all metals are solid in nature. Yes, if they are metals, they are solid, and non-metals, they are either gases or solids. Gases like oxygen, nitrogen, chlorine, or they may also be solids like phosphorus, sulfur. Yes, then metal oxides, they are solids, and non-metal oxides, they are gases like NO2, CO2, etc. In this way, you can have some general idea about the physical state symbols of reactants or products. Okay. Now let us see the steps for balancing a chemical reaction. By taking an example, iron reacts with steam to form iron oxide plus hydrogen. This equation is not balanced as the number of atoms on both the sides are not same. So let us balance this by following the steps. The first step is draw the boxes around each chemical formula. We need to draw the boxes because in order to balance a chemical reaction, we will add coefficients here in front of the molecules or compounds. But we are not supposed to change the subscripts here. We should not alter the chemical formula of the compound. Please keep in mind this one. Okay. So now we get, if you alter the subscripts, then identity of the molecule or compound it will get changed. Okay. Now in the second step, count the number of atoms of each element. Okay, count number of atoms of each element. I will write here element number of atoms on LHS on RH. Okay, so what are the elements present here? Iron, hydrogen, oxygen. Yes, number of iron atoms on LHS only one. Here there are three, and hydrogen there are two hydrogens here. On RHS side there are two hydrogen atoms. What about oxygen? Here there is only one oxygen atom. What about here on the RHS side there are four hydrogen atoms. So the atoms of iron and oxygen are not balanced. They are not same here. So we need to balance the equation now. Okay. Now start balancing the equation with the compound having more number of atoms. Okay. The equation with compound having more number of atoms. Here oxygen atoms are more in number. So let us first balance the oxygen atoms. As there are four oxygen atoms here on the LHS also, there must be 4 oxygen atoms. So what I need to do is I need to keep the coefficient 4 here. By multiplying 4, we get 4 oxygen atoms on LHS also. Yes, here I will multiply the number of oxygen atom by 4. Once I add coefficient 4 here, it belongs to both the elements as it is a whole one molecule. It is a single compound, so it belongs to, the coefficient will belongs to both the elements. So once I add the coefficient here, the number of hydrogen atom is also affected and number of oxygen atom is also affected. So keep in mind that. Okay, so multiply it with 4. Next, balance the remaining elements by adding coefficients. Now balance the remaining element one by one. As I have already said that once the coefficient is written here, the number of hydrogens are also affected. So it becomes 4 into 2, 8 here. The number of hydrogen atoms is 8 in number. Okay. So now I need to balance hydrogen atoms also. How can we balance the number of hydrogen atoms? Here there are 2 hydrogen atoms, simply by writing the coefficient 4 here, so that 4 into 2 will be 8. Okay. I will multiply 2 into 4 here. So that number of hydrogen atoms will also be 8 in number. Okay. See here, the number of hydrogen atoms are balanced is equal to 8. And number of oxygen atoms are also balanced. Then what is the remaining element which is need to be balanced? Iron atom. Yes. Now, how can we balance the number of iron atoms? Here there are 3 iron atoms. Once I write the coefficient 3 here, then it will be 3 iron atoms on LHS also. So these coefficients which are written in front of the chemical formula of the compound are called as stoichiometric coefficients. Okay, I will write here 3 to make the number of iron atoms same on both sides of the equation. Here I have multiplied the number of iron atoms by 3 so that I get number of iron atoms same on both sides and hydrogen atoms same on both sides. Oxygen atoms are also same on both sides. Yes, now this equation is balanced. You can check the correctness of the equation just by counting the number of atoms of each element on both sides. Okay, check the correctness of equation by counting number of atoms of each element on both sides. So then again what we need to do is, in a balanced chemical equation, the state symbols for all the reactants must be reactants and products must be mentioned. Means if they are in solid state, we will symbolize it as S. If they are in liquid state, L. If they are in gaseous state, G. If they are in the form of aqueous solution, then we will write AQ. Okay, so directly I will write the equation now. Balanced equation: 3Fe plus 4H2O gives Fe3O4 plus 4H2. Okay, then state symbol for iron is S, as it is in solid state. It will react with steam, so I will write here G, as water is in the form of steam. Then oxide of iron Fe3O4, it is in solid state. Then as we know, hydrogen is in gaseous. Okay, this is a balanced chemical equation. Let us see some of the examples of balanced chemical equation. Let us see the examples for balanced chemical equation. Photosynthesis reaction, where plants use sunlight and chlorophyll, where carbon dioxide and glucose, oxygen are in the dissolved form. So this is an example for balanced chemical equation, where we have made the specifications of physical states and also the number of each number of atoms of each element are same on both sides of the reaction, and also under what condition is the reaction taking place is also mentioned here. So this is a balanced chemical equation. We can also write another example: carbon monoxide plus hydrogen. This is methanol. Okay, this is gas and this is also gas. This is liquid, and this reaction takes place at 340 atmospheric pressure. So this reaction is also balanced chemical equation. So to make the number of hydrogen balanced, I need to write here 2. So count the number of atoms on each side. Yes, all the atoms are balanced now. Okay, these are examples for balanced chemical equation. So you need to remember that in a balanced chemical equation, the number of atoms of each element are same on both sides, and also you should make the specification of physical states of each reactant and product. Okay, but one thing you have to note here is, do not alter the formula of chemical formula of elements or compounds. Do not alter the chemical formula while balancing. Okay, and one more thing you have to remember is, it is a hit and trial method. You have to make the practice of many number of chemical equation by solving them, then you will be used to it. Okay, keep practicing lot of questions on balancing chemical equations. We will also be solving the number of examples of chemical equations here. Then to note about the physical state symbols, we cannot always remember all the states of reactants and products. Yes, so we can have some general specifications like metals, they are solid, although there may be some exceptions, but we can have general idea about it. Okay, non-metals, they are generally gases or solids. And salts, the soluble salts can be indicated as aqueous, okay, which are soluble in water. And oxides of metals, that is metal oxides, are usually solid, like magnesium oxide. Okay, then non-metal oxides are usually gases. So please note these points so that it will be easier for you to write the general physical states symbols in the chemical reaction. Okay, first let us solve some of the simple examples. See here, the number of magnesium atoms are same on both the sides. What about oxygen atoms? Here there is only one oxygen atom, but there are two oxygen atoms here. So by writing the coefficient 2 here, I get number of oxygen atoms same on both the sides. But what has happened to the magnesium atoms now? Here there is only one, but here there are two magnesium atoms. So again I need to write the coefficient 2 here so that the equation is balanced now. If the equation is simple, then we can solve it in a single step. But if a reaction seems complex for you, then write the elements, write the number of atoms of each element on both sides and start balancing them. Okay, formation of water. See here, the number of hydrogen atoms are same on both the sides, so no need to worry. Balance the number of oxygen atoms. Write 2 here so that the number of oxygen atoms are same in number. But now the number of hydrogen atoms have become 4 here. There are only 2 hydrogen atoms here, so again make it 4. So now the equation is balanced. Okay, let us try one more example. Methane reacts with oxygen to form carbon dioxide and water. Okay, see here, there are 4 hydrogen atoms here which are more in number. So let us first balance the hydrogen atoms. Here there are only 2, so I will write the coefficient 2 here so that the number of hydrogen atoms become 4. Okay. What about oxygen atoms now? There are 2 plus 2, 4 oxygen atoms here. So in order to make it 4, I will multiply by the coefficient 2. See, now the reaction is balanced. Number of carbon atoms are same, hydrogen atoms are same, and oxygen atoms are also same. Okay, let me take another one example. Manganese dioxide plus HCl, it forms manganese chloride plus water plus chlorine. See here, there are 4 chlorine atoms here. As they are more in number, let us first balance the chlorine atoms. Or if the reaction seems complex for you, first write the number of atoms of each element, oxygen and hydrogen. Number of atoms on LHS and on RHS. Okay. Then the number of manganese atoms are 1, 1 on both the sides. And chlorine atoms, here there is only 1 chlorine atom. Here there are 4 chlorine atoms. Here there are 2 oxygen atoms. Here there is only 1 oxygen atom. What about hydrogen? Here 1 and here 2. Okay. Now the number of manganese are same on both the sides. What about chlorine now? We have to balance it. How can we balance? By writing the coefficient 4 so that the number of chlorine atoms will become 4. So after writing the coefficient 4 here, the number of hydrogen atoms have also got changed to 4 here. Okay, then these are balanced. What about oxygen and hydrogen? They are not still balanced. So let me balance oxygen atoms. In order to make it 2, I will write the coefficient 2 here. See the number of oxygen atoms on both the sides of equation. Here there are 2. Here also there are 2. Now this is also 2, this is also 2. Both are balanced. On writing the coefficient 2 here, I will get the number of hydrogen atoms as 4 here. So all the atoms are balanced in this equation. Okay. In this way we have to solve by hit and trial method, or you can also use one trick, general trick. If you are unable to understand which atoms are to be balanced first, just follow the order. Even though it is a hit and trial method, we can have one general trick like first metals are balanced, then non-metals, excluding oxygen, then oxygen, last hydrogen. We can follow this order also. Okay, usually the single elements are balanced in the last so that it is very convenient. Okay, let me solve another one example. Nitric acid plus calcium hydroxide, it forms calcium nitrate plus water. Write the number of atoms of each element, calcium, nitrogen, oxygen, hydrogen on LHS, on RHS. Okay, calcium atoms, there is only 1 on both the sides. What about nitrogen? Here there is only 1 nitrogen. Here there are 2 nitrogens. And what about oxygen? 3 plus 2, 5. Here 3 2s are 6 plus 1, 7. What about hydrogen? 1 plus 2, 3. Here 2. So it is balanced. Now I need to balance nitrogen. So by writing the coefficient 2 here, I get the same number of nitrogens on both the sides. Next, by writing the coefficient 2 here, the number of hydrogens have also got changed. 2 plus 2, 4. What about oxygen? 2 3s are 6 plus 2, 8 here. Okay. Now this is balanced. What about oxygen atoms? Here there are 7. In order to make it 8, I can write the coefficient here 2 so that the total number of oxygens becomes 8 in number. 3 2s are 6 plus 2, 8. Okay. Then number of hydrogen atoms have also got changed. 2 2s are 4. Now check whether the equation is balanced. 1 1 2 2 8 8 4 4. Okay. This is how we balance the chemical equation. So my dear students, now we are going to study the different types of reactions. We will study combination reaction, decomposition reaction, displacement, double displacement and oxidation reduction reaction. Okay, let us study them one by one. First is combination reaction. Here the name itself indicates we are combining the reactants to form a single product. Okay, it is a combination reaction when two or more elements or compounds react together to form a single product. The reaction is called as combination reaction. The reaction is called as combination. Yes. In the general form, I can write two or more substances react together. They combine together to form a single product. This is a general representation of combination reaction. You have to remember that the product is formed, that is only one product formed here. Okay, we can give many examples. Reaction of magnesium with oxygen, then formation of carbon dioxide is a combination reaction, then formation of water. These are different examples for combination reaction. That is the two or more elements or compounds are reacting here, but the product formed is only one. That type of reaction is called as combination reaction. The product formed is only one. Okay, and one more important example is there, that is formation of calcium hydroxide. That is mentioned in your NCERT syllabus also. When calcium oxide reacts with water, it forms calcium hydroxide. Is the equation balanced? Yes, the equation is balanced. It is calcium oxide, also called as quicklime. It is also called as quicklime. It reacts with water to form calcium hydroxide. It is also called as slake lime. And also in this reaction, heat is liberated. Okay, along with the formation of product here, heat is liberated. Such type of reaction where heat is liberated, they are called as exothermic reaction. The reaction where heat is liberated along with the formation of products along with the is called as exothermic reaction. So you have to remember that formation of calcium hydroxide is a exothermic reaction. When you are asked to identify the type of reaction, you have to remember here 2 points. It is a combination reaction, and also it is exothermic reaction because heat is liberated. Okay, this is point to be noted. Then this reaction has also the commercial importance, that is the calcium hydroxide is used in the whitewashing of walls. Okay, calcium hydroxide is used in the whitewashing of walls. Once the wall is coated with this calcium hydroxide, what happens? It will react with the carbon dioxide present in air, okay, to form calcium carbonate, so that the shining appearance will be seen after 2 to 3 days of whitewashing. Okay, this you have to remember. It may be asked in your examination which compound is used for whitewashing of walls, and why does it look shine after some days. Okay, it is due to the reaction of calcium hydroxide with carbon dioxide present in air. Okay, then few more examples for combination reaction. Let us see examples of combination reaction. You have to remember the definition and you must be able to identify the reaction. This is solid, this is gas, this is solid. Formation of hydrogen chloride, H2 plus Cl2. It is also example for combination reaction. Formation of ammonia. This is also combination reaction. Okay, these are some examples for combination reaction. So you must remember that there is a formation of only one product here. Okay, and also we have talked about exothermic reaction here. Yes, if the heat is liberated, we call that reaction as exothermic reaction. One more example you have to remember is respiration is also an example for exothermic reaction. Okay, so I will write it as a note. Please note this point. Respiration is an exothermic reaction. What happens there? Glucose combines with oxygen to form carbon dioxide and water with the liberation of energy. So it is a example of exothermic reaction. Balance this. Okay, shall we move to the next part? So now we are going to study the decomposition reaction. What are decomposition reactions? The reactions in which a single substance breaks down to form two or more simple substances. Okay, then we call it as decomposition reaction. When a single substance decomposes into two or more simple products or simple substances, the reaction is called as decomposition reaction. Yes, only a single I can represent it as a single reactant decomposes to form two or more products. These are simple products. Okay, let us see the examples. When ferrous sulfate crystals are heated, ferric oxide is formed, sulfur dioxide is formed, and sulfur trioxide is formed. Okay, it is ferrous sulfate. These two are gases. Okay, we get ferric oxide, sulfur dioxide, sulfur trioxide. It is a decomposition reaction where a single reactant breakdowns into two or more simpler products. That type of reaction is called as decomposition reaction. We can also write another one example. When calcium carbonate is heated, we get calcium oxide plus carbon dioxide. Okay, calcium carbonate, calcium oxide, carbon dioxide. Yes, in this way decomposition reactions occur. Okay, here you are seeing, in order to carry out the decomposition reaction, we are supplying heat, means we are supplying energy. So that type of reactions where energy is absorbed are called as endothermic reaction. Okay, we have to note it down. The reactions in which energy is absorbed, the reactions in which energy is absorbed, the reactions in which energy is absorbed are called as endothermic reaction. The energy may be absorbed in the form of heat, light, or electricity. So based on the type of energy that is used in the double decomposition reaction, we will come across three types of reactions here. So based on type of energy that is absorbed during a reaction, we will classify decomposition reaction into thermal decomposition, photolytic decomposition, and electrolytic decomposition. Okay, thermal decomposition. In decomposition reaction, when it is carried out in the presence of heat, we call it as thermal decomposition. The reaction is carried out in presence of heat. For example, this is a important example. Decomposition of lead nitrate. Here decomposition occurs in the presence of heat to form lead oxide, nitrogen dioxide, and oxygen. Okay, lead nitrate, these are gases. Lead oxide, nitrogen dioxide, and oxygen. My dear students, you have to remember all the subproducts here. Okay, whenever a reaction is carried out like this, please remember all the subproducts that are obtained in the reaction. Okay, means what are the products that are obtained in the reaction. Okay, here lead nitrate decomposes into lead oxide, nitrogen dioxide, and oxygen. Okay, now it is thermal decomposition. Then next is photolytic decomposition. You have to remember examples for these type of decomposition reactions. Okay, the decomposition is carried out in presence of sunlight. Decomposition is carried out in presence of sunlight. Example, decomposition of silver chloride in the presence of sunlight. It forms grayish silver plus chlorine is liberated. It is silver chloride, silver. The white silver chloride, when it is exposed to sunlight, becomes grayish in color because it is due to the formation of silver. You have to remember the color for particular reaction. It may be asked in your examination. Okay, what is the color of product that is obtained when silver chloride is decomposed in the presence of sunlight? Okay, in this way you have to remember. Then decomposition of silver bromide in the presence of sunlight, write the state symbols. Okay, in this way photolytic decomposition occurs in the presence of sunlight. Okay, remember one thing here, these reactions are used in black and white photography. These reactions are used in, yes. Now next we are learning electrolytic decomposition. Electrolytic decomposition. When the decomposition reaction is carried out in the presence of electric current, the decomposition reaction is carried out in presence of electric current, then it is called as electrolytic decomposition. Example, electrolysis of water, where water is decomposed into hydrogen and oxygen. So this is a electrolytic decomposition reaction where we are decomposing the reactant in the presence of electric current. Okay, so now let us discuss displacement reaction. This reaction in which an element displaces another element from its compound. That type of reactions are called as displacement reaction. The reaction in which an element displaces another element from its compound is called as displacement reaction. The word itself indicates to displace from its compound. We can write the general formula as see here. The element A has displaced B from this compound. Okay. So AC is formed. This is a general equation. Okay. When one element displaces another element from its compound, then we call that type of reaction as displacement reaction. Okay. Let us see some examples here. Iron reacts with copper sulfate solution to form iron sulfate plus copper. Here see what has happened. Iron has displaced copper from its compound to form iron sulfate. So copper is formed here. This is iron. Yes, this is copper sulfate. It is in the form of aqueous solution. Now iron sulfate is formed. The blue color solution of copper sulfates becomes pale green in color. It fades. The color blue will fades because there is a formation of iron sulfate here. The iron has displaced copper from its solution. So the new compound formed here, that is pale green in color. It may be asked in your examination like, why does the solution blue color solution of copper sulfate fades? Okay, you have to write the reaction and you have to mention what has happened, because iron has displaced copper from its solution to form iron sulfate. Okay, and copper is formed. In this way you have to write. Then let us see one more example. Zinc also reacts with copper sulfate solution to form zinc sulfate plus copper. It is zinc. This is copper sulfate. Yes, then zinc sulfate is formed. Here also see, the zinc element has displaced copper from its solution, that is copper sulfate solution, to form zinc sulfate and copper. Okay. Also lead reacts with copper chloride to form plus copper. This is lead. This is copper chloride. This is lead chloride and copper. Okay. In this way lead has displaced copper from the copper chloride solution. Okay. So one thing you have to note down here is not all the elements will displace every element from its solution. Only the reactive elements will displace other elements from their solution. Okay. This iron has displaced copper from this copper sulfate solution. It means that iron is more reactive than copper. Here zinc has displaced copper means zinc is more reactive than copper. Lead has displaced copper here means it indicates lead is more reactive than copper. So only the reactive metals will replace the other element that is less reactive than that of that element, so that compound is formed here. For reference you need to see here activity series where the metals are arranged in the decreasing order of their reactivities. As you go down, the reactivity decreases. It is a most reactive and it is a least or less reactive. The metals that are placed above in the activity series can displace the metals that are below in the activity series. So calcium can displace magnesium, magnesium can displace aluminium. Okay, but iron cannot displace calcium in this way. Copper cannot displace zinc. If I write here copper plus zinc sulfate, what is the reaction? What is the products that are obtained? If it is asked in your examination, you have to apply this knowledge that copper is less reactive and this will not replace zinc. So here no reaction occurs. Simply do not replace every element. You have to first study the activity series. You can note down here. Okay, those metals which can replace are placed in the upper part of this series. Okay, please remember this while solving the equations of displacement. Okay, this is all about the displacement reaction. Then let us move to the next part. Next is double displacement reaction. The reaction in which there is a mutual exchange of ions between the reactants. It is called as double displacement reaction. The reaction in which there is mutual exchange of ions is called double displacement reaction. See here, in the earlier case only one element was displacing the another element. Okay, but here what happens, there is exchange of ions between the reactants. Like if it is AB plus CD, then it forms AD plus BC. Okay, there is mutual exchange of ions between these two reactants, which results in the formation of two different products. Okay, let us see the examples. Reaction of sodium sulfate and barium chloride. Reaction of sodium sulfate and barium chloride. It results in the formation of barium sulfate and sodium chloride. Okay, it is sodium sulfate. This is barium chloride. This is barium sulfate. This is sodium chloride. See here, there is a mutual exchange of ions. The sodium cation of this reactant reacts with chloride anion of this reactant to form sodium chloride, and barium cation of this reactant reacts with sulfate anion of this reactant to form barium sulfate. There is a mutual exchange of ions. See here, the solid precipitate is formed, means whenever an insoluble substance is formed in a reaction mixture, that we call it as precipitate, and the reaction is called as precipitate reaction. Here it is a white solid. When an insoluble substance is formed in a reaction, then the reaction is called as precipitation reaction. Okay, this may be also asked in the way that what is the solid substance that is formed when sodium sulfate and barium chloride are reacted, and it may also be asked that if this equation is given and you have to identify what is the type of reaction, then you need to remember both. It is double displacement reaction and also a precipitate reaction. The product that is formed, that is insoluble product that is formed in a reaction mixture, is called as precipitate. Okay, let us see few more examples of double displacement reaction. Examples. If you come through many number of examples, then it will be easier for you to identify the type of reaction. Okay, lead nitrate reacts with potassium iodide to form lead iodide and potassium nitrate. It is lead nitrate. This is potassium iodide. This is lead iodide. It is yellow solid. It is a precipitate formed in a reaction. It is yellow PPT. Then it is potassium nitrate. This is also a double displacement reaction where there has exchange of ion taken place. Lead reacts with iodide anion to form lead iodide, and potassium has interacted with nitrate ion to form potassium nitrate. Okay, then let us move to the next one. Balance this equation. Yes, now the equation is also balanced. Next example, calcium hydroxide plus nitric acid to form calcium nitrate. This is calcium hydroxide reacts with nitric acid to form calcium nitrate and water. Okay, this is also a double displacement reaction. So far we have discussed the different four types of reaction up to double displacement. Then let us move to the next part, that is oxidation reduction. Now we are going to discuss about oxidation and reduction. Oxidation means oxidation is addition of oxygen to a substance or removal of hydrogen from a substance. Oxidation is addition of oxygen to a substance or removal of hydrogen from a substance. It is called as oxidation reaction. Suppose we are adding oxygen to a substance, it is a general equation, then also it is called as oxidation. If you are removing hydrogen from a substance, then also it is called as oxidation reaction. Okay, then what do you mean by reduction? It is quite opposite. Reduction is addition of hydrogen to a substance or removal of oxygen from a substance, then it is called as reduction. Okay, suppose we are adding hydrogen here, it is called as reduction. If we are removing oxygen, then also it is called as reduction. Okay, this is a general idea about oxidation and reduction. Let us see the examples for them. When copper is heated in the presence of air, that is, it reacts with oxygen to form copper oxide. Okay, this is a oxidation reduction because copper has gained oxygen here. It has reacted with oxygen to form copper oxide. As there is gain of oxygen, we call it as oxidation reaction. Yes, it is oxidation. The brown color of copper is changed into a black solid. It is of copper oxide. This is copper oxygen changed into copper oxide. Yes, this is oxidation reduction. It changes into a black colored copper oxide. If you see another example from the same case, that if copper oxide is made to react with hydrogen, what happens? The reverse reaction takes place where copper is formed and water. Here copper oxide is again converted into copper, means here the oxygen has been removed. This is called as reduction reaction, as there is removal of oxygen, means copper oxide has undergone the reduction process, reduction reaction. It is copper oxide, hydrogen, copper is formed again. Yes, in this reaction what happens? Copper oxide is reduced to copper, but hydrogen is oxidized to water. Copper oxide is reduced to copper. This is reduction, this is oxidation. If one element is donating oxygen, then it is obvious that another element is accepting it. Okay, so in the same reaction itself we are observing oxidation and reduction. So such a reaction is called as redox reaction, means the oxidation and reduction reaction takes place simultaneously. You have to note down it. In your examination, if an equation is given and you are asked to find out which element is undergoing reduction, which element is undergoing oxidation, you have to write it. Suppose here, which one is undergoing reduction? Copper oxide. Which one is undergoing reduction? Which one is undergoing oxidation? Hydrogen. Yes. And one more thing important here is the element or the compound which is reducing another element, that is called as reducing agent. Okay, here hydrogen is reducing copper oxide, that is hydrogen is called as reducing agent, and copper oxide is oxidizing hydrogen, it is called as oxidizing agent. Okay, it is simple. If it oxidizes, then it is called as oxidizing agent. If it reduces, it is called as reducing agent. Okay, so the reactions in which oxidation and reduction occurs simultaneously, means in a single reaction itself we are seeing here simultaneously, or called redox reaction. Okay, so the last part of this chapter is corrosion and rancidity. What do we mean by corrosion? You people might have seen that many metals, when they are exposed to the outer environment, the surface of those metal will change in color. Okay, like copper, it has some black coating or green coating, and silver is also coated with black when it is exposed to the external environment. And also you might have seen many iron materials, when they are exposed to the moisture, they become brownish in color. Okay, why does this happens? It is due to the corrosion. What happens is the outer layer of these metals are attacked by the environmental factors like air, moisture, acids, gases, etc. There they react with them to form a stable compound, so that the color of the outer layer will get changed. Okay, let us see what is corrosion here. When metals are attacked by environmental factors like moisture, air, acid, etc., or any other, or any gases like carbon dioxide, sulfur dioxide, etc., then the metal is said to be corroded, and this process is called as corrosion. Means there is a deterioration of the metal, means the quality of metals will get decreased as its outer layer becomes corroded. Okay, there are many examples like rusting of iron. What happens in rusting? There is a brownish layer is formed, it is of iron oxide, as iron reacts with the moisture there. Okay, rusting of iron. And then there is a black coating on silver metal. What is that? It is due to the formation of silver sulfide. Okay, it attacks with the sulfur oxide present in the air to form silver sulfide. Okay, and then also there is a green coating on copper, that is also due to when copper reacts with oxygen present in air, it forms oxides. Okay, and also it reacts with carbon dioxide to form carbonates. This results in the formation of green coating there. Okay, copper carbonate, copper oxides are formed. This is due to corrosion. What happens? What is the demerits of the corrosion? Here the quality of the metal will get decreased. The metals are usually having good tensile strength. Yes, what happens once they get corroded? They will become brittle in nature. So there is a damage to the materials which are made up of the metals, like car bodies and railings which are made up of iron. Okay, what are the metallic bodies that are used in the manufacture of vehicles, buildings, etc.? They will get corroded, which results in the decrease in quality of those metals, and also damage will happen. Okay, how can we prevent this corrosion? Okay, there are many methods. It depends on what type of corrosion it is. If you want to prevent the rusting of iron, we will paint the materials of iron. Okay, and also oiling, greasing is also possible. So we have to shield the outer part of the metals from air and moisture so that they get protected from external factors. Okay, and also we may mix the metals with other metals to enhance their properties, that is making of alloys is also possible, so that we will prevent the corrosion. We will be studying the prevention of corrosion in chapter 3 also. Okay, so you now have understood about corrosion. Okay, next is rancidity. Rancidity means it is the process of oxidation of oils and fats where we can notice the change in taste and smell. Okay, that process is called as rancidity. The process of oxidation of oils and fat which can be easily noticed by change in smell and taste is called rancidity. When the items which are deep fried in oil are kept for a longer duration of time, you can observe that there is a change in taste as well as smell. Yes, it is due to the oxidation of the oil, oxidation of the food materials that are deep fried in the oil. Okay, then how do we prevent the rancidity? Rancidity has caused due to the oxidation, so we have to add some antioxidants in order to prevent the rancidity. Okay, how do we prevent it? Addition of antioxidants to the materials of oils and fats, antioxidants, then keeping food items in airtight container so that it will not be attacked by the external air, then keeping food items in refrigerators, and also flushing the food packets with nitrogen as it is an antioxidant, nitrogen gas. Yes, this is how we can prevent the rancidity. This may be asked in your examination, like what are the preventive measures for rancidity, and then why are the packets of chips they are flushed with nitrogen, that is in order to prevent the rancidity. Okay, so far everything is clear related to this chapter. Okay, so this is all about the chapter 1 chemical reactions and equations.